Okay. All right, guys, so y'all have kind of those initial differences just kind of based on what it looks like? Yes? No? Okay, perfect. All right, so I'm going to add a couple things to it. All right, so now you may have a little bit more information than what you had before. So look back at those differences that you initially saw and adjust it if you need to. Maybe you already were ahead of the game and kind of knew where I was going with it. But you can adjust it to maybe what you think of it is now. So even if you said maybe on the left-hand graph it's going to continuously go, well, now you can say what's going to continuously go. Okay, so tweak those just a little bit if you need to. Alright guys, so now we're going to talk a little bit about what you guys have noticed the differences are, and then we'll actually tell you the names of it, what they really represent, things like that. So someone from Christian's group, can you guys go ahead and tell me maybe something you noticed that's different?
We saw that the first graph kind of the population was it's going to continue to increase by 5%, and then the second graph, it kind of like caps off, like it's reached its point in that population. So it's like it's projected by like 50, like it's about that stuff.
Perfect. Okay. So does everybody get something similar to that, or anybody have something different? Good job, guys.
Carrying capacity.
Carrying capacity. That is something, yeah. I didn't know how much I've probably gotten into that so far. So, anybody else have anything different?
Like different amounts of time.
Huh?
Like the one on the left looks like a shorter time period, maybe. And
Okay.
the one might be a longer time period.
So you think that the left graph takes longer to get up? Is that what you're saying?
I think since it's like a shorter time period, it keeps increasing. But the one on the right may be like a longer time span, so it increases and then it'll eventually flatten out.
Okay. Okay. Got it. Anybody different? Something else? Okay. Christian and Paris kind of hit it on the spot a little bit. So for our left-hand graph, as they had said, this is going to continuously grow, right? It's almost like there's no end to it. So it's going to be, as long as the resources are available, it's going to keep on thriving. Whereas over here, it starts off, kind of steady, just like this one. It slowly rises up, but then it kind of does cap off. There's something affecting it to make it level off, okay? So the actual names of these graphs in population, and I drew that way too tall. All right, so the left one is exponential growth. And the right one is logistic growth. Has anyone taken stats yet? Or is in stats? Yeah. So these should kind of be a little familiar. So, exponential growth and logistic growth. So exponential growth is going to continue to grow, okay? There is nothing that's going to stop it. The resources are pretty much available however much it needs until something does happen and kind of turns it more into that logistic growth. But logistic, it's more, we'll ask you guys, which one's more realistic? If we're thinking about a population, is the left graph or the right graph more realistic? The logistic, yeah, definitely. But we kind of know there's not a population that's perfect, always thriving. Something's going to happen. And we'll kind of get into the different factors that can happen. Or you did on your worksheet a little bit last night. But it's going to keep on thriving until something kind of stops it and gets it to its max. Okay? So now we're going to label these things. I'm going to come over here. So these two graphs are going to have different points where we can label. So if something says, refer to the blank phase, we're going to start labeling that. Okay, so we have the lag phase. The exponential phase. All right, so we have the lag phase, exponential phase, deceleration phase, and equilibrium. Okay, so on this graph, can someone tell me what phases will be represented? What you think the phase will be represented here? All right, exponential. So where would the exponential go? Like right here?
No.
Kind of going up. Okay. All right, and so exponential over here would be about the same. All right, anything else? We'll go ahead and label. Group over here, if y'all have something. Okay. Yep. All right, so that leaves what? The lag phase. So where does it go? The beginning, right, on each one. Whoop. All right, so go ahead and make sure you label your graphs like that. You can just do something like this to the side, and then do like this numbers on the graphs. So each of them do have two things in common. They will all have a lag phase, and that's, you can remember that as it's lagging. It's kind of lagging, right? It's kind of slowly about to accelerate, but it's not super fast or anything. And then the exponential growth, they both obviously have, but the deceleration, the equilibrium phase, that is what the exponential graph is lacking, because there's not going to be that since the resources are unlimited. So make sure you go ahead and get that written down. And someone said this earlier, but what's another word for, so equilibrium is kind of a broad term, but if we're focusing again back on population, what does equilibrium mean? The what? What? Carrying capacity, right. It's equilibrium or carrying capacity. Which is represented just by big K. You may also see an exponential graph labeled something differently. Actually, both of them labeled something differently. If we're going to relate the alphabet to these graphs, what do you think this graph is going to be? What? A? Not A. Like, what is this actual line? What letters does it look like? J, right. So exponential growth you can also see as a J curve. So that's just something you may encounter. Okay? And so this, what letter does this kind of look like? S, right? So an S curve.